revision of ordinary differential equation by doing some MCQ questions. So let's start. Now this is our first question, and in this question they are just asking you about order and degree, right? And order is what? Order is the highest order derivative occurring in the given differential equation. So here, what is the highest order derivative? So highest order derivative is 3. So here order is 3. Okay. And what is degree? Degree is the power of highest order derivative. What is the power of this? 2. So degree is 2. Okay. So that means third option is correct. Fine. And in fact we don't need to waste our time for degree, because here see order 1, obviously this is not correct, this is not correct. Okay, so order 3, that means there is a chances to have this, but we need to check the degree because there is another option that is none of this. Okay, now let's do the next question. So this is our next question. Here again they are asking about the order and degree, but here we are having like this equation. So as you know, before calculating this degree and order, your equation should be free from radicals and fractions. So here we are having power 3 by 2. In order to get rid of this, what we need to do, we will just take the square on both sides. So what you will get? You will get this thing. And on the other side, you will get d square y over dx square whole square, right? Now we don't need to expand this thing because order and degree both are depending on the highest order derivative. And here, what is the highest order derivative? This one is the highest order derivative. So highest order is 2, and what is the degree? What is the power of this? Degree is also 2, right? So B is the correct option. Now let's move to the next question. Now class, in this question they have given you this y and they are asking you about the corresponding differential equation, right? Now see, there are two arbitrary constants are involved. Okay, so that means corresponding differential equation will have the order 2. Okay, we know this thing, order of differential equation is actually equals to number of arbitrary constants. Okay, so from this fact you can see the C option is not correct because order of differential equation is 1 here. Okay, so differential equation which you will get corresponding to this will have order 2. So either A or B or C can be correct, right? Now one method is to eliminate this A and B, by just differentiating this equation 2 times. But another method which you can use for MCQ questions, like you can differentiate this y. Okay, you can find the values of these derivatives and you can substitute the value and check which differential equation is satisfied by this y. That will be your correct answer. Now let's find the derivative. So y is given as a e power 2x plus b e power minus 3x, right? So what is dy over dx? So dy over dx is 2a e power 2x plus minus 3b e power minus 3x. Similarly, what is second order derivative? So second order derivative is d square y over dx square. Now that will be 4a e power 2x plus 9b e power minus 3x. Now see, just substitute the value of d square y here and y here. So you can easily see that this equation is not satisfied by this y, right? Because this will not give you 0. Fine, this will not give you 0, so this is incorrect or this is wrong. Now come to the B option. Now B option is saying d square y plus dy over dx minus 6 into this equation. So you can easily see 4 plus 2, 6 ax minus 6 into this. So here you will get 6, right? So if you add, this will be cancelled. Similarly, if you add these two things, then again 9 minus 3, that will be 6, and 6b, this will be same. So when you subtract, these things will be cancelled, and that means B is the correct option. Now let's move to the next question. Now in this question they are asking about the general solution of this equation, right? And here this question can be solved by three methods. Okay, first is exact form, like you can check whether this is exact or not. So this will be dy minus y dx equals to 0. This will be m dx plus n dy form. Okay, you can solve this by that method, or the same question can be solved by using Leibniz form. So you can convert it to Leibniz form, like you'll get x plus 2y cube over y equals to dx over dy, and from this you'll get x by y plus 2y square equals to dx over dy, and from this what we'll get, dx over dy minus 1 by y x equals to 2y square. So you can see this is Leibniz form which we have done. So you can easily solve the question by that method. Now third approach is different from these two, and that is applicable for MCQ questions. Okay, now let me explain that thing to you. Now what we'll do, we'll find out the value of derivative from this, and we'll check which option is giving you the same value for derivative. Okay, for example, if I solve this thing, what we'll get? We'll get dx over dy equals to x plus 2y cube over y, right? This is what we are getting as dx over dy. Now come to the option number 1. So if I use option number 1, x is equals to y cube plus c. So what is the value of dx over dy? That is 3y square plus c. Now we have to check whether this thing is same as this or not. So see, what was x? X for A option is, x was y cube plus c. Now you can check one thing. Are you getting the same answer? So this is 3y cube plus c, right? And here we have y. No, this is not same, because y will be cancelled. You'll get 3y square. But here along with the c, you'll get c over y. Are you getting my point? So option A is not correct. Fine. Now come to the next option. Next option is B, where y is given as x cube plus xc. Okay, now here if you differentiate, what is the value of dy over dx? That is 3x square plus c, right? Now here from this, what is the value of dy over dx? So dy over dx is equals to y over x plus 2y cube, right? Now here what you can do, you can place the value of y here. So what is the value of y? So that is x cube plus xc. Now here again 2x square plus xc. This is x cube, sorry. Now cube of that. If you solve this, will you get this expression? No. So that means B option is also not giving you the same thing as of dy over dx, which is given to you according to this question. So B option is also incorrect. Now come to the C option. C option is giving you x is equals to y cube plus yc. So if you find dx over dy here, what you'll get? 3y square plus y, sorry, plus c, right? Now come to this. Here, if I place the value of x, if I place this value of x, so what you are getting? Y cube plus yc plus 2y cube over y. So kindly check, are you getting the same thing? So this is 3y cube plus yc over y. So this is giving you what? So this is giving you 3y square plus c. Now you can check, both the things are same. So if you differentiate this, then you are getting the same derivative value as of this. So that means option C is correct. Okay, so option C is correct. This is how you can save your time, and if you are not aware of any concept and you know the derivative, you can solve these questions. This question, you can see they are just asking about the solution, and here like this is, you know, Leibniz equation, so you can directly solve it. But whenever they have provided you any condition, first of all we'll check that which option is satisfying this condition, because by using this condition we can eliminate some options. Okay, so like here we have 2x is equals to e power x. Obviously they have not given you any y here, this will be totally wrong. Now come to this. From this, what is the value of y? From option B, we are getting y is equals to this. So when you place x0, y should be 1 by 2. So kindly check, are you getting that same thing? So yes, this is satisfying the thing. Okay, we are getting 1 by 2. And for C option also, we are getting the same thing. Like this is over 2. So if you place 0 here, this will give you 1 by 2. Now because this option is not giving us much, so we have to do something else. So one thing is direct method that you already know by using the Leibniz form. Second is just like the previous question, we'll just find the value of derivative and substitute that value here. Okay, so let's solve this. For this one, y is, for B option, y is e power x over 2, right? So what is dy over dx? Dy over dx is e power x by 2 as such. Now see, if you place this value here, what you will get? So dy over dx plus y will be equals to what? E power x by 2 plus e power x by 2. This will give you e power x, which is your right hand side. So that means B option is satisfying your condition. Okay, so the B option is correct. Now if you check C, y is e power minus x by 2. So what is dy over dx? Dy over dx will be minus e power minus x by 2, right? And here if you substitute the value here, what you'll get? So dy over dx plus y equals to, this will be equals to e minus x over 2 plus e power minus x by 2. So this will give you 0. This is not giving you e power x, right? So that means C option is incorrect. So this is how you can do the question. Now this is the next question, and this is again Leibniz equation. Okay, so Leibniz equation is of the form dy over dx plus py equals to q, where this p and q are function of independent variable, and here independent variable is x, right? So coefficient of dy over dx should be 1, but here in this equation they have given you cos square x. So what we will do, we'll just divide both sides with cos square, okay, in order to get the coefficient of this thing as 1. Okay, so what we'll get, so if you divide this with cos square x, so this will be cancelled, okay, and we'll get this thing dy over dx plus 1 by cos square is 1. What? 1 by cos square is secant square x. So secant square x and y equals to tan x over cos square x means tan x over, it will be same. Okay. Now for this equation, what is the integrating factor? Integrating factor is e power p dx. And here what is your p? P is the coefficient of y, okay, and that is secant square. So what is the integrating factor? Integrating factor is e power secant square x dx. And what is the integration of secant square? That is tan x, right? So this is first option is the correct one. Class, this is Bernoulli's equation, okay. One is the direct method which you can follow, but here for MCQ I'm going to do another thing. So by using the another approach, what we'll do, we'll find the value of dy over dx here, okay, and then we'll find out the value of derivative from the options also. Whatever the option will give you me same value of this dy over dx, that option will be correct. Now let's do this. So from the given equation, what is the value of dy over dx? This is the value of dy over dx. Now just change the secant y to cos. Okay, so this will be 1 by cos y. Same here. This tan x is what? This is sin y over cos y 1 plus x, right? Now see, this is the value of dy over dx. Come to the options now. We'll check the options. So first option is giving you sin y equals to e power x plus c 2 plus x. So differentiate both sides with respect to x. You will get cos y dy over dx equals to, now if you differentiate these two things by operating product rule, what you will get? So here derivative of this thing will be e power x 2 plus x as such, plus here you will get e power x plus c as such, derivative of this thing will be 1. Okay, so dy over dx will be equals to e power x 2 plus x over cos y plus e power x plus c over cos y. Now if I place sin y as this, will you get the same thing? Let's check. So 1 plus x e power x as such over cos y plus Here if I add this thing e power x plus c 2 plus x over cos y into 1 plus x, you can see. In fact, in this condition also we are having 1 plus x here, but in this option they are giving you 2 plus x. Okay, from option A we are getting 2 plus x. So option A is totally wrong. You can just connect these two things. These are not same. Now come to the option number B. Option number B is giving me sin y as e power x plus c into 1 plus x. Again, we'll do the same thing with option B also. Differentiate both sides with respect to x. So dy over dx equal to e power x 1 plus x plus now e power x plus c as such, and here we'll get derivative of this thing, that is 1. So what is the value of dy over dx? That is e power x 1 plus x e power x plus c, okay, over cos y. Now let's check whether for this value of sin y we are getting the same thing as of this or not. So for this, if I place value of sin y which is given in option B, what will we get? Over x plus c 1 plus x over cos y 1 plus x. This will be cancelled. Now you can see this thing and this thing is same, right? And next term is also same. This is same thing, so that means option B is correct. We don't need to check for the further option. In fact, you can get the idea that if you place 3 plus x, obviously you'll get 3 plus x here, but in given dy over dx, we have 1 plus x here. So obviously option C will not be correct, D will also not correct. Okay. Now next move to next question. Here class C, this is the higher order differential equation with constant coefficient. So one method is the direct method, like complementary solution by using auxiliary equation. And see, class, particular solution, particular integral is two different things. Particular solution is when you assign some value to the constant. Okay. So here they have given you two conditions also. Sometimes we are able to solve the question by conditions only. So here, like, what is the first option? So in first option they have given you e power t plus e power minus 4t. So what is the first condition? First condition is saying y will be 0 at t is equals to 0. Second condition is saying dy over dt will be 0, sorry 5, this will be 5 at t is equals to 0. So we just need to check this thing. So what is y of 0 here? So if you place 0, this will give you 2. But this should be 0, right? At t0, y should be 0. So that means option A is incorrect. Now come to the option number B. Option number B is giving you e power minus t minus e power minus 4t. So if I give you, if I assign t is equals to 0, what we'll get? So this will be 1 minus 1, 0. Okay, so first condition is satisfied. Come to the second condition. What is dy over dt here? That is e power minus t minus plus e power 4t negative. So here if I place t0, so at t0, what we will get? E power 0 and plus 4 e power 0. So this will be what? Minus 1 plus 4 equals to 3, not 5. It should be 5. So that means option B is also incorrect. Now come to the option number C. Okay. So option number C is what? Option number C is y is equals to minus e power t plus e power minus 4t. So if again I place 0, so t0 means this will be e power 0, right? So this will be 1 plus 1. So this is giving you, sorry, here we have negative also, minus 1. This is giving you 0. So first condition is again satisfied. We have to check the second one. Dy over dt, what is dy over dt? That is minus e power t and minus 4 e power minus 4t. If you place t0 here, so what you will get? Dy over dt will be minus e power 0 minus 4 e power 0. So this will be minus 5, not 5. So again C option is also not correct. So we are left with only D. D is correct option. Though if you want to check, you can check it like what is Y. So if you place 0 here, this will give you minus 1 plus 1. So first condition will be satisfied. And what is the second condition? What is dy over dt here? Dy over dt is minus minus plus e power minus t and plus 4 e power 4t. So if you place t0, what you will get? e power 0 plus 4 e power 0, so that will be 5. Okay, sometimes more than one option used to select used to satisfy the condition. In that case we have to solve the question by using this thing, or you may check which option is satisfying your equation. Okay, but sometimes like in this question we are not we don't need to do anything, like we can just solve the question by using these two conditions only. Okay, by using these two conditions. Now let's move to the next question. Next question is about complementary function or complementary solution of this equation. Okay, now one method is the direct method. That what is the auxiliary equation? That is d square minus 4d plus 3 equal to 0. Find the roots. What are the roots? Roots are 1 and 3, so which are real and distinct. Real and distinct, right? So for real and distinct root, how we used to write the complementary function? Complementary function is c1 e power 1 first root into x is the independent variable, plus c2 e power 3 into x. So option C is correct. But we have another approach also, like if you are not aware of the things that how we are writing the solutions and all, then you can do one more thing. That is, you can check for the different options. Like you have to find this thing, like d square y minus 4dy plus 3y should be 0. You can check which option is satisfying this condition. For complementary solution, your option must satisfy this thing. Okay, like you can differentiate this 2 times and place the value here. You can find first order derivative, place the value here, then put the value of y here. And if this is giving you 0, not x cube, then that will be complementary function or complementary solution. Okay, for complementary solution we used to take 0 here. Fine, this is the second approach which you can use if you are not aware of the things. The next question is again of higher order differential equation with constant coefficient, and they are asking you about particular integral now. Now one thing is the direct method. Second thing is you can find the second order derivative, first order derivative, and you can place the value, and whatever the function is satisfying your equation, that is the correct one. Okay, so for example for sine x you can take what is d square y over dx square. First of all, what is dy over dx? What is dy over dx? That is cos x. What is d square y over dx square? For option A, I'm solving this, minus sin x. Okay, now place the value, minus sin x minus cos x minus 2. Y was what? Y is sin x. So what you are getting? Minus 3 sin x minus cos y. But we don't need negative. So that means this is incorrect. Okay, now if you take option B, that means y is cos x. What is dy over dx? Dy over dx is minus sin x. What is d square y over dx square? This is minus cos x. Now place the value here. So this will be minus cos x minus this thing is minus minus plus plus sin x minus 2 cos x. So this will be minus 3 cos x plus sin x. Again, this is not your right hand side. So this is again wrong. Now come to the next one. C option. What is C option? C option is giving you y is equals to minus sin x. Dy over dx will be minus cos x, and d square y over dx square will be positive sin x, right? Positive sin x. Now place the values here. So this will be sin x minus minus plus cos x and minus 2 into minus of sin x. What you'll get? You'll get 3 sin x plus cos x. Now you can see this is the same answer as of this. So that means option C is correct. Okay. Similarly, you can check option number 4 also. So in this question, they are just asking about the type of the equation. So in this equation, if I multiply x square on both sides, so what we will get? So this will be 2x into x square dy over dx equal to 2 log x whole square x square into x square. So this will be cancelled. So ultimately we'll get x square d square y over dx square 1x will be cancelled, plus 2x dy over dx equal to 2 log x whole square. Now observe one thing. Here whatever the power of x we have, same order of this derivative we are having, right? Like here x is having power 1, same order we have for this derivative, right? So this is what? This is Cauchy linear equation, right? So B option is the correct one. Now this is our next question, and this is also of same type, like this is also Cauchy linear equation. One method you already know, the direct method, but another method we are going to just find, because they are asking you complementary function. So we'll just find out the things, like we'll find out the derivatives from the options, and we'll check which option is giving you zero answer. For complementary solution, as I told you, that your this left hand side should be 0. Okay, for option A, let's start with option A. If I take option A, A is this c1 plus c2 over x. What is dy over dx? Dy over dx is c1 will be 0 minus c2 over x square. What is d square y over dx square? This is 2c2 and x cube. Now if I place the values here, what will you get? So minus 2c cube, let me write it here. So if I check this thing, what we will get? So we will get, what is d square y over dx square? That is 2c2 over x cube, my plus 1 by x, and this is what? Minus c2 over x cube. Okay, so what we are getting? Minus 2, this is minus 3c2 over x cube. This is not equals to 0, so that means option A is wrong. Now check the option number B. So option number B is y is equal to c1 plus c2 log x. So what will be dy over dx? Dy over dx will be 0 plus c2 by x. What is d square y over dx square? This is c2 over x square along with negative. Now place the values here. So this will be d square y over dx square plus 1 by x dy over dx. So see, what we'll get, I'm going to write it here. So just place the values which we have calculated. So what is d square y over dx square? That is minus c2 over x cube. And what is this? Plus 1 by x and c2 over x, c2 over, sorry, here we have x square. Okay, now minus c2 over x square plus c2 over x square. What we are getting? 0. So we got the 0, so that means option B is correct. Okay, we don't need to check for the other options. This is the next question. Again, they are asking you about the particular integral. Now, question is same, equation is same, but here we need to find a particular integral. Now, class, for this, what we will do, we'll just check that which option is giving us this thing. Okay, so what is for option A? What is dy over dx? So dy over dx is 3 1 by x. What is d square y over dx square? This is 3 minus 1 by x whole square. Correct? Now place the values here and check whether you are getting this thing or not. So this will be minus 3 1 plus x whole square plus 1 by x into 3 1 plus x. Right? So you can just solve this. So minus 3 1 plus x whole square. Here we'll get 3x. Okay, and here you'll get 1 plus x. So you can see, you can just solve this and you'll get 3 by x 1 plus x whole square, which is not equals to this thing, right? So option A is wrong. Now come to option number B. What is option number B? Option number B is 3 log x. So what is dy over dx here? Dy over dx is 3 by x. D square y over dx square is what? Minus 3 by x square. Now place the values here. Okay, so this is minus 3 over x square plus 1 by x into 3 by x. Okay, so what we are getting? We are getting minus 3, you can take common, 1 by x square. Okay, plus 1 by minus 1 by x square. So this is 0, not This is not giving you 12 log x over x square. Are you getting my point? So this is actually what? This is giving you 0. So this is again wrong option. Now come to the next one. Now option number C. This is giving you y is equals to log x whole square. So what is dy over dx? Dy over dx is 2 log x, right, into 1 by x. Now what is d square y over dx square? This is giving us 1 by x into 1 by x plus log x into minus 1 by x square, right? So if I solve this, this is equals to 2 1 by x square minus 1 by x square log x. So you can just write it like 2 over x square 1 minus log x. Now if I place the value here in this of these derivative, what we'll get? So we'll get, just substitute the value, so we'll get 2 over x square 1 minus log x and plus 1 by x into 2 log x. Okay, fine. Now see, are you getting this thing? So 2 over x square minus log x and 2 over this will be cancelled, and finally you will get this. This will be cancelled and you will get 2 over x square. But this is not same as this. There should be 12. That means option C is also incorrect. So option D is correct, but let me show you how. So here D option is giving you y is equals to 2 log x whole cube. So what is dy over dx? Dy over dx is 2 into 3 6 log x whole square, right? What is d square y into 1 by x also? So dx square, this will be equals to, first of all take 6 common, so 2 log x into 1 by x plus here log x whole square, and sorry, here we'll get x square, and here log x as such, and minus 1 by x square. Alright, so this will be what? This will be 12 log x over x square and plus or minus, you may take 1 by x square log x whole square, right? Whole square. Now just place the value in the given equation here. So what is the value of d square y over dx square? Place it. So this is 12 by x square log x, okay, minus 1 by x square log x whole square, fine, and here we have 6 also, sorry, 6, and again we get 6 over x square log x, okay, 1 by x is this and another thing is this. This will be cancelled and you will get this thing. This is same as this. So D option is correct. Okay. Now this, see class, this is the question of Legendre's equation, as this factor is having same power as of this order. Okay, here also. So this is Legendre's equation. So one method is just to substitute the values, okay, by taking y this, find second order derivative, 5 first order derivative, and just substitute the value. Whatever the value will give you 0 answer. Okay, because for complementary function or complementary solution we need 0. Whatever the answer will give you 0, that is the correct answer. But if you solve it directly, we'll put 1 plus x equals to e power z, okay, and this will give you z is equals to log 1 plus x. So in your answer you must have 1 plus x, log 1 plus x form. So from this thing I can cancel 3 options, like here we are having 1 minus x, this is wrong, here we are having x, wrong, 2 plus x, wrong, okay. But still if you want to solve it further, so we know what we used to do, 1 plus x dy over dx will be equal to dy into b, where this b is actually coefficient of x. Here coefficient of x is 1, so this will be 1, and this d is derivative with respect to z, okay. And similarly 1 plus x square d square y over dx square, this will be equals to what? This will be d into d minus 1 into y along with b square. So b square is 1, so we don't need to write this thing. So if you place this value in the given equation, what will you get? D minus 1 y plus dy plus y equal to 0. So this will be d square minus d plus 1 y equal to 0. This will be cancelled. Now just write the auxiliary equation. This is higher order differential equation with constant coefficient. So auxiliary equation is d square plus 1 equals to 0. So what are the roots? The roots are plus minus iota. So what is the solution for this? So complementary function is e power 0 z, because z is the independent variable, c1 cos z, because imaginary part is 1, plus c2 sin z. Now if you place the value of z, what is z? Z is log 1 plus x. So if you place this value, this is 1 cos 1 plus sorry, here we have log also. So log 1 plus x, fine, plus c2 sin log 1 plus x. That means which option is correct? This thing. And you may have sine here, cos here, but we don't have any problem with the constant, because you may have c2 along with sine, c1 along with cos. Okay, that is not a problem, because constant we have just, we can name them anything. Now, this is a simultaneous differential equation. So here one method is you can directly solve this. Now, because they are asking you to find the value of y, so we have to eliminate x. So dy over dt plus x is given as 0. Okay. So here x and y both are dependent variable, where t is the only independent variable here. Okay. So if you differentiate this equation again, if you differentiate this again with respect to t, what will you get? D square y over dx dt square plus dx over dt equal to 0. Now from this equation, what is the value of dx over dt? From this, dx over dt is what? Y. Okay. So now place this value here. So d square y over dt square plus this is dx over dt is what? Y. This is higher order differential equation with constant coefficient. What is the auxiliary equation here? Now here auxiliary equation is d square plus 1 equals to 0. So what are the roots? Roots are plus minus iota. So what is the solution? Solution is complementary function, or complementary solution is c1 cos t plus c2 sin t. Right? Because real part is 0. So e power 0 something will be 0. Okay. So this will be 0, so that will give you 1. So answer is constant cos t plus constant into sin t. So this e power t, that means this is wrong, this is also wrong, this is also wrong. So B is the correct option, right? So this is the question of simultaneous differential equation. So here we are having two dependent variables, x and t, sorry, x and y. Okay, and there is one independent variable, that is t. Okay, and here they are asking us to eliminate y, and then what we will get in the form of x. This is the question they are asking. So see, here I'm using the notation for derivative respect to t. Okay, so here what is this d over dtx? This is dx plus 2y equal to minus sin t, right? And what is this? This is dy minus 2x equal to cos t, right? Now we need to eliminate y. So what I'll do, I'll just equate the coefficient of y from both the equation. Now in this equation, y coefficient is 2, and here we have y coefficient d. So operate d operator on this, on both sides, and here multiply this equation with 2, so that we can have the same coefficient. So this will give you d square x plus 2 dy equals to minus derivative of sin t, and here you will get 2 dy minus 4x equals to 2 cos t. Now here d square x is fine, we need to eliminate this thing. So what should I do? So we need to subtract this. Okay, so this will be d square x, this will be cancelled if you subtract, plus 4x, okay, equals to, here what is the derivative of sin t? Minus sin t derivative is cos t, and here we are subtracting this thing, so here you will get negative minus 2 cos t. So this is d square plus 4x equals to minus 3 cos t. So what is the correct option? B is the correct option. all about this. Thank you very much. I hope I have explained everything. Okay, and with this, we have revised all the things, and I have told you the different approach which we can use, okay, to save the time. And I'll see you in the next lecture.